Let us start our eighth part of compile design, runtime environment. How do we allocate the space for the generated target code and the data object for our source programs? The places of data object that can be determined at a compile time will be allocated statistically, but the place for some of the data object will be allocated at the runtime. The allocation of deallocation of the data object is managed by runtime support package. Runtime support package is loaded together with generate target code. The structure of runtime support package depends on the semantics of the programming language. Each execution of procedure is called activation of the procedure activations. An execution of a procedure starts at the beginning of the procedure body. When the procedure is completed, it returns control point immediately after the place where the procedure is called. Each execution of procedure is called as an activation. Lifetime of activation of a procedure is the sequence of the steps between the first and the last steps in the execution of the procedure. Okay, if A and B are procedure activations, then their lifetime are non-overlapping or nested. If the procedure is recursive, the new activation can begin before earlier activation, the same procedure is as ended. In activation tree, you can use a tree to show where to control enters and leaves activation. In activation tree, each node represents the activation of the procedure. The two represent the activation of the main program. The node A is a parent of the node B. The control flows from A to B. The node A is left to the node B. The lifetime of A occurs before the lifetime of B. Activation tree, program main, procedure S, begin and end. Okay, procedure B, procedure Q, begin and end. So begin Q followed by S, the end. Begin P, the S, ended. So see, listen here. Enter main program. After the main program enter into the procedure P. After enter the procedure P, enter to the procedure Q. Then immediately procedure Q is completed, exit the procedure Q. Then enter to S. Just subprogram. Then immediately exit from this. Then after that exit from the P. Then entered S, entered S, entered S, exit S. Exit main program. There is no overlapping. Like this, every procedures are executing in the compiler. The example activation record. 3 is the main program, enters the P. So once it enters the P means it enters to the Q. The Q is completed, you go for the X. The S is completed, return back to the main program. Again, S program subroutine procedure will be started, it ended. So it has without any overlapping. So all the processes will be activated. This is called activation tree. Control stack. The flow of control in the main program corresponds to the depth first travels from the activation tree that starts at the root. Visit the node before its children. Visit a node before its children and recursively visit children at each node of the left-right order. The stack can be used to keep track of the live procedure activations. The activation record is pushed into the control stack as the activation starts. The activation record is popped up when the activation ends. When the node N is on top of the control stack, the stack contains a node along with the pop from the N to the root node. Variable scopes. The same variable can be used in different parts of the program. The scope rules of the language determine which declaration of the name applies when the name appears in the program. An occurrence of the variable is local if the occurrence in the same procedure within the name is declared. Non-local, otherwise it is called as non-local. A procedure P, variable B is real, procedure P, variable A is integer, begin A equal to 1, B equal to. Here A is a local variable, here B is a non-local variable. So this is a variable scope. Runtime storage organization. This is organization of heap storage. It's a code. The memory allocation for the code determined by the time of compilation. Static area. Location of the static data can also be determined at the time of compilation. Stack. Data object allocated at runtime. It is called activation record. Okay. So otherwise, dynamically allocated data object is runtime. For example, memory allocation area in C language. So when it's required allocated, when it's completed its work, it should be allocated. This is a runtime storage definition. Activation records. Information needed by a single execution of a procedure is managed by using continuous block of storage called activation record. An activation record is allocated when a procedure is entered and it is deallocated when the procedure exited. The size of the size of each field can be determined at the compile time. So, except that the procedure has a local variable and its size depends on its parameter, its size is determined at each runtime. Activation record. Return value. The return value of the called procedure is returned in this field of the calling procedure. In practice, we may use machine register for the return value. Actual parameter. The field of actual parameters used in the user calling procedure would supply parameters to the called procedure. Optional control link. The optional control link points to the activation record of the caller. The optional access link is used to refer to the non-local data held in the other activation records. Shared mission status. The field for shared mission status holds the information about the state of the mission before the procedure is called. Local data. The field of local data holds data, but local data can execution of the procedure. Temporaries. Temporary variable is stored in the field of temporaries. The activation record. If the main program starts that it will be entered to the procedure queue with variable A, then enters the procedure queue with variable B. So its main program, P is entered first. After P is completed, go for the queue. Once queue is completed, return back to the main program. So it back on again starts to the starting with the main program. Yes. So like this, activation record example. Activation records for the recursive procedure. Recursive procedure. The main program was that the function q integer, the function will be executed. After end of this function, begin again the key will be called with another TCP. So, like recursion, the same program will be called again and again. Self-calling is called as a recursive procedure. So, P is a procedure, Q with data 3, Q with data 2, and a Q with data 1. So, similarly, the same program repeatedly calling this type of procedure is called as activation records for the recursive procedure. Creation of activation record. Who allocates an activate record of the procedure? Some part of the activation record of the procedure is created by the procedure immediately after the procedure is entered. Some part of the created by the caller of the procedure before the procedure is entered. Who deallocates? Callee deallocates on the part allocated by the callee. Caller deallocates the part allocated by the caller. Creation of activation record. Return value. The caller activation records are the actual parameter, optional control link, optional access link, shared mission status, local data, temporaries, all these are caller responsibility. After that, all the values are coming return value, return to the main program. Here we are passing for the actual parameter, which is passed to which is defined in defined procedure, optional control link, optional access link, shared mission status, local data, temporary is a calling responsibility. It's a caller responsibility, it's a calling responsibility. Variable length data. Return values. The variable length data is collected after the temporaries, and there is a link from the local data to the array. Dangling reference. Whenever a storage is deallocated, the problem of dangling reference may be occur. With such non-local data, scope rules of the language determine the treatment of the reference to non-local names. Scope rules. Lexical scope determines the declaration that applies to the name by examining the program text alone at compile time. Most closely, nested rules is used. For example, POSIX. Dynamic scope determines the declaration of the supply applies to a name at the runtime. For example, list and APL. Lexical scope. The scope of a declaration in a block structured language is done by mostly closed rules. Each procedure will have its own activation record. Procedure begin end blocks. Treated same as a procedure without creating most of its parts activation. A procedure may access to non-local name using access link in activation record or displays it. Procedure parameters. Main program, access link, queue, access link. So how the parameters are passing one to another is explained here. Main program, procedure P enter parameter A, procedure B is executing here, then immediately call the procedure queue. So procedure P S will be called begin end. So begin end procedure parameter with yes, begin end. So access link must be paused with the procedure parameters. Display an array of pointers of activation record can be used to access activation record. This array is called as displays. For each level, there will be a array entry. It's a current activation record at level 1, current activation record at level 2, current activation record at level 3. Accessing non-local variables. Program main variable A integer, user P variable B integer, begin Q and user Q variable C integer, begin C equal to plus B and so begin B end of the program. So non-local data, how you are accessing one to another, accessing non-local variables. Yeah, accessing data 1, data 2, data 3. Main program, when the variable A is integer, procedure P is entering here. So B is integer here, B variable is declared here, begin Q end. Procedure Q again, C is a variable here, integer, begin C is equal to plus B. So both will be added. C will be, this data, B and C will be added, it's non-local variable, and displays the result at the end. Parameter passing. The parameter passing, three methods we are discussing here, call by value, call by reference, call by name. Some other issues. Symbol table hold scope information. Dynamic scope uses control link. Dynamic scope using control link similar to access link. Dynamic storage allocation, heap management, different allocation techniques. Thank you for listening to this lesson.